dysfunctional that here. I'm in the process of beginning to build my 1 kilowatt solar system, and a little bit later this year, if everything goes well, I'm going to increase it by 1 kilowatt, so I'll have a 2 kilowatt system. I'm pushing to have 3 kilowatts of power. And this is strictly on troubleshooting that we're dealing with right now. So let's take a look at what we have. This is a knife switch, and it's made by BAOMAIN. It's called a safety knife switch, 3-pole double throw. I only need a single throw, but you get what you get. On opening the box, this is here, and it rattles. What those rattles are the tie downs on the inside of this thing. So let's take a quick look at what's inside there. Alright, what we've got is we have these pieces right here. Have trouble getting that one out. And these pieces screw down onto here, onto this, so that you can hook your leads up. Now the voltage that this thing says it will handle is 380 volts at 100 amps. That is a lot of power. That's like dictator type of power. So what we're going to do is we're going to put these things in, and I'm going to walk you through the setup. I'm actually going to put this inside an enclosed electrical box, so I'm not going to be putting this cover back on. I kind of like the way it looks like this better than with that. With that said, my panel is going to be divided into 3 different arrays. The reason for that is so that if I'm having a problem with an array, I can troubleshoot that array, isolating it from everything else. When most systems are built, everything wires together into one contiguous wiring setup. In solar, now this isn't true of wind power, but in solar, panels almost never fail unless they are physically damaged. In almost every single case of solar, it's going to be a connection somewhere. And I'm going to digress for one moment to tell you a story. When I was going through school for my degree, I did an install job for a woman on the cheap because, you know, I'm not a licensed installer or anything. And I put up 400 watts of power for her. And these were thin film technology. They're probably still producing what they're supposed to be producing, but thin film is the bottom of the rung. The only people that should be buying thin film are the people that are, they're trying to go on the cheap. It's not a good way to go, just put it that way. Alright, so I'm going to have my panels in 3 arrays. Oh, I didn't finish this. Alright, nobody should be buying thin film, which rolls out like a mat and it's sticky and it sticks down. When I built her panel, or her array, and hooked up the batteries and the inverter and all that stuff, I told her that she did not have enough power there. Her refrigerator alone was going to burn, I think, 2,000 watts more than she was making, and a good amount more than her batteries would allow for. When batteries are in series, give you whatever the amperage of the battery is. So if you're running 3 100 amp batteries, you have 100 amps coming off of it. If they're in parallel, you would have 300 amps if you have 3 batteries. Well, she had her batteries in series parallel, and she had 200 watts of power. That was it. The total, 200 watts. She had 4 batteries. And I tried to explain to her it wouldn't work. But when I put her array in, that's from the panels all the way down to the inverter, I hardwired everything, and any connection I soldered. I didn't go with the little snap together connections that everybody's familiar with. I actually soldered every single connection. The reason for that is, as I have said, in a solar panel it almost never fails unless it is damaged. However, almost every problem with solar energy is a connection problem. It's not the panels. Now you get hit with big hail and you got a problem, but be that as it may. So what I want to do is be able to isolate out my panels in sections and be able to find out what's going on. Now I have 12 panels, so I'll have 3 panels set up, 3 panels set up, and 3 panels set up. If for some reason I'm not getting the wattage that I should have, and I'm not pushing the amps, I can pull this out of the closed position to the open position, and then I can test here and on the return line to that section of panels. If it's good, then I can go to the next one, and I can find out what's wrong with my panels. There are some people, I want to say they live in Montana. I used to watch their channel a lot, and they were having problems with their panel, and the guy covered them to test them, but he didn't cover the back of them. He didn't completely surround them in darkness. And I sent him a note and I said, those panels have to be in complete darkness, otherwise you're still going to be getting a reading off the panel. And I don't think he understood what I was saying, but panels actually will take in light from the back side. And there is a company, I just went blank on them, there's a company that is now mirroring the back side of a solar panel, so that as the light passes through your PN junctions, the light is reflected back into the PN junctions, and it gives you much more energy than you would normally get. Much more efficient. I wish I'd thought of it. I wish the patent was mine, but it's not. But this is my knife switch, 380 volts at 100 amps, and this was not expensive. It's about $20-something roughly, and that's as of February 2024. But I've got to put all these pieces together. I'm going to have to find out what size these things are so that I can get the proper connectors for these. And just remember something, if you have a solar panel and you're not getting the energy that you think you should, start from the panel, check there, see if you're getting the volts and the amps that you should be pushing, and then go through every place you have a connection and make sure that that connection is patent. The wind is really kicking up, so I'm going to go ahead and sign off dysfunctional vat out.